All right, let's get this show on the road, folks. Let's hit it. Let me turn off the lights so we can start today's stuff. We actually have a number of things that we want to talk about today. How went all of your texturing and materialing last week? Good? Everyone kind of getting the general gist of it to a certain degree? If you feel like a duck out of water, don't worry that you will overcome that fear and that anxiety. You will get better at it. And doing materials and textures is not an easy thing. It's not an impossible thing either. You know, it's something that we all can learn. But I recognize firsthand that there is a learning curve that all of us has to go through when we're approaching this really kind of challenging content. This is something that you're going to do for the rest of your careers in 3D. You're always going to be lifelong learners in this. You know, I've been doing this for a long, long time, and I'm even still learning new techniques, new ideas, and new approaches that will ultimately give me a much more high-quality result, a much more customizable result. So there's always going to be things to learn. The first step is always the most shaky one in this process. You definitely feel like you're an infant learning how to walk, and in many ways, you are. But hang in there. If this was impossible in your mind, you will get easier. You will have an aha moment where like, I get it now. I understand what this whole polygonal material thing is all about. And just when you think you get the hang of it, or you've gotten the hang of it, and you're really comfortable and really good, I'm going to throw something new at you, and it's going to completely change your perspective on this whole materialing, texturing gig. So, hang in there. It's going to be quite an adventure over the next period of years as you become more and more comfortable with inside this pipeline. Today, I want to spend our efforts talking about a new way of approaching three-dimensional modeling. Last week, as you guys know, we spent all of our time talking about materials and textures. Well, today we're going to kind of jump back in to the modeling side of it and get a little bit more detail or explore some new tools that will allow us to gain a little bit more detail. It may help if I plugged in my computer monitor. Yeah, here we go. Sorry about that, folks. And it's not mirroring. Excuse me. Let me just fix this real fast. Oh, it's really starting to rain now. Brilliant. Okay, here we go. Well, let's try this again. Let me just revisit my live stream, make sure I'm still going, and I am. Great. Okay. So today we're going to spend almost all of our time talking about a new approach to three-dimensional modeling. This new approach is called subdivision surface modeling, and there are a lot of benefits associated with sub-D modeling, but there's also some new challenges in this realm that make it a little bit more difficult to use. We'll go over those pros and cons here in a minute. So just from kind of the 10,000-yard description, today we're going to focus almost all of our energy on modeling. Let's revisit some of the expectations that I'm looking for you guys to complete for this week's content. So if we go to the GCOM 402 section of renderography.com, you can see that I have the subdivision surfaces class post established, and here we go. Let's just take a look at what we're going to be building. So this week you're going to be building a stoplight. Actually, you're going to be building a couple different stoplights. The application of all the tools and the application of the technique is really what's important here. We'll talk about how to achieve this higher quality result here in a minute, but this week we're going to focus entirely on subdivision surface, hard surface modeling. It's going to be kind of a fun one, and we'll also get an opportunity to continue to flex our materialing and texturing skills too. Our lab work this week is going to be a really, really fun lab assignment. It's going to challenge you on a technical level to produce some very, very specific results. You're going to be building a Lego brick for your lab assignment this week. But it's not just any Lego brick. This Lego brick has to be constructed out of what's going to be called a contiguous polygon. So this is going to be one contiguous shape, so one interconnected polygon. We're not going to be burying polygons like we have in the past, where you take a cylinder and just kind of bury it straight into the top of our cube, right? That'd be way too easy. No, we're going to be doing something a little bit more advanced and talking about how we literally can take a square peg and shove it in a round hole, okay? That's what we're going to be looking at this week, okay? The correct construction technique in the subdivision surfacing world that allows us to connect geometry together correctly, okay? So we're going to spend a lot of time this afternoon looking at the construction technique that allows us to get this result. Okay? Yes, sir. Are we actually modeling all the crevices and stuff on the inside? You can, absolutely. You will get some creative freedom to do what you want to do for the bottom. I'm really concerning myself with this top portion here. I think the most important takeaway for this lab assignment is that it's going to be all one interconnected piece. And of course, we'll talk about how we can achieve that as we go through today's content. Sound good? All right. Subdivision surface modeling is a really, really, really important technique that we need to keep in mind and consider as we go through our kind of journey into the world of three-dimensional modeling. Sub-D modeling is relatively new. It's only been around for about maybe 10 or 12 years, but inside that period of time, it has exploded in popularity. Because sub-D modeling allows us to gain a much higher quality result, but not at the expense of having millions upon millions of polygons within our scene. It also allows us to work with very familiar tools in a very familiar workspace to gain the results that we're after. Come on in, gentlemen. Just getting started. Find a machine. Let's look at some examples of the application of sub-Ds and start to explore what they really look like. I'm just going to go to the Layout tab inside of Modo, and down here, I'm in the Meshes subcategory, and I'm going to look for, let's go to Animals, and I'm going to use the classic Modo Rhino. This guy has been around for just about forever. Let's just take a look at what this little rhino has to offer. Now, this is a pretty cool model. If you look at what's constructed here, it's beautiful, right? It's got a whole series of compound curves. All the different forms and lines are flowing into each other at very odd and different angles. So this would be a pretty difficult model to make. If you look carefully here, do you really see any faceted edges? Do you see any polygons? No. Think back to your coffee cup, right? When you're making the cylinder of your coffee cup, you saw a whole bunch of faceted edges, right? I kind of recommended that you keep your geometry relatively low res for that coffee cup, and a lot of you guys chose to build your that base cylinder with 16 sides or maybe 12 or 14 sides, right? Rock and roll, that's what we did. Okay, but even at even with a cylinder that has 16 sides, you still saw some hard edges where the planes were changing direction as they went around the circumference of our cylinder. Do you see any of those hard plane changes here? No. This is a subdivision surface object. Okay? This is the big benefit of working within subdivision surfaces, is that it takes a very faceted piece of geometry and converts it into a surface where all that information is smoothed out. We don't see any polygons here. We see nothing but smooth surfaces, and it's pretty fantastic. One of the great things about subdivision surface objects is that we don't have to physically convert them or bake them or freeze them into its current form. We always still get access to its original polygonal cage. So all of our sub-D objects are going to start off very similarly to the way we start any object for that matter. The tools are the same. The construction technique is almost the same. There are some small considerations and some additions that we need to keep in mind. But at the core, we're still using our basic modeling tools to make an object whose illusion of quality is much, much higher than it actually is. Let me convert this on the fly back to its original polygonal form. And there it is. There's the original object. That's the original polygonal cage that the computer is smoothing when I hit my special key. Yeah. I'm just hitting tab. Yeah, the tab key inside of Modo is the toggle button between our traditional polygonal cage and a subdivision surface object. Just hitting the tab key. And you can see when I'm looking at the original polygonal object, now we see all the polygons, right? We see all the faceted surfaces. We see all the hard edges that come with this object, and it doesn't look all that great, right? Actually, it looks quite horrible in actuality. But the moment we hit the tab key, the computer is going to analyze all these surfaces and apply a whole series of really, really fancy algorithms to smooth out all that geometry and give us the illusion of perfect curvatures. Pretty neat, right? So at the core of this, when we hit the tab key, we're applying a new algorithm to the surface of our mesh. And this algorithm is responsible for smoothing everything out. Now, have we increased the number of polygons on this object? No, it's still the same, right? So this is really a smoothing algorithm. We haven't added new geometry, but we are asking the OpenGL engine inside of Modo to display this geometry much differently. Let's take a look at what I'm talking about here. I'm going to hit the tab key, and I want to kind of bring to the surface a little number that everyone should be very aware of. So right now, here's the original piece of geometry. Pretty low res. If you go in and look at, all this, you can definitely see the hard surfaces as they cruise through in here. Okay, kind of ugly in its polygonal form. But check it out. If we go to the bottom right-hand corner of our OpenGL viewport, the computer is giving us access to a whole series of little chunks of information, one of which is the number of OpenGL polygons that the computer is currently registering. Right now, it's 9,012. This is the actual polygonal count of this object. So this is only a 9,000 polygon little rhino. That's pretty good. That's not too bad. However, when I hit the tab key, that subdivision surface algorithm is coming into play. And the OpenGL viewport is giving us the illusion of smooth curvatures as it starts to iron out all those plane changes. And the illusion that we're crafting here is an object that has, 145,000 polygons. So we're not really adding new polygons, but the computer is rendering more polygons on the back end. Kind of nice. Actually, it's kind of nice. And this is just our first baby step into a much larger world of subdivision surfaces. Towards the end of the semester, when we start really truly forming organic structures and analyzing the production technique for characters, we're going to explore a different algorithm in the sub-D world that allows us to interactively change that number on the fly.
And that would work great with Lighthouse because all that land, there was a lot of sharp points.
A lot of sharp edges. Hitting the tab key, smoothed it all out. Yeah, for sure. For sure. Yeah. Absolutely. Okay, let's take a look at some examples here of how we can apply our subdivision surfaces. Oh, actually, let me take a step back. A lot of folks, they think sub-Ds are only limited for those out there in the character world. And I think the character modelers definitely have something to say about that. This technology, you can see the benefit of this technology in the character world. We can make something that's relatively low resolution for a character's body or a face, hit the tab key, and the computer is going to smooth all that geometry out for us. Okay. However, us in the hard surface world also get a significant advantage and benefit from using this chunking technology as well. I think I use sub-Ds on almost everything now. I am a sub-D loop slice modeler. I think that's my forte. I see the world in that perspective quite often. A great example of that is if you go over to our class blog, down in the footer here, I've given links to some very, very cool projects. If you look at the Camaro project, there it is. That's a pretty awesome Camaro. This was modeled by a student named Cody Tibbetts. He actually works over in the design lab. He and I spent an entire semester in an independent study doing this model together, and it turned out very, very nice. Beautiful, beautiful model of a car. Well, the original base cage of this is clearly all polygons, but the end result in the render, we transformed it into a subdivision surface, and we can and all those hard planes were smoothed out instantly. Pretty cool, huh? If you look at some of the other examples on my Flickr stream, and I'm just kind of playing around with this whole Flickr stream thing. It's interesting to me. You can see a lot of really great examples of sub-D models in the hard surface world. Okay, here's another one. All subdivision surface polygons on this one. You don't see any sort of illusion and apparent nature of those hard faceted edges. Everything's smoothed out. However, with the hard surface world, when we're making mechanical objects, we have to play with a new set of rules. We have to design our models and construct them in a very specific way so that when we do need to define a very abrupt change in plane, like a 90-degree angle on a piece of metal, that we can retain the shape, but get the edge quality that we're after. Okay, let's get back to it. So I mentioned this during the break, and I want to mention it again. Hopefully, I don't want to do this every day, but I will, okay? If it forces my hand, I'm going to do this. Stop using the viewport navigation icons in the upper right-hand corner of the screen. Don't use these. If I catch you using them, I'm gonna whip out like a ruler and like smack your hand, like whoosh, like you'd see in like a kung fu movie. Whoosh, no, whoosh, yeah, don't do that. Don't do it. Now, and here's the reason why. There's an actual reason behind this. Okay, by taking your mouse cursor away from the place that you're working, you're slowing down your workflow significantly. Okay, we want to keep our tools, and in our case, our mouse, where we are working. By constantly having to go up to the upper left, right hand corner, press and hold the buttons, we're stopping our workflow. Okay, take a good 5 minutes. If you haven't mastered the keyboard shortcuts yet, take a good 5 minutes and just do this: orbit, 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 orbit. Zoom in, zoom out, zoom in, zoom out, zoom in, zoom out, and then just commit those keyboard shortcuts to memory. As a small refresher, let's just go through the keyboard shortcuts once again and remind everyone as to what we're doing here. Okay? So, help me out. What is the keyboard shortcut for the orbit command? Option what? Option left mouse button, right? Option or Alt left mouse button. And that's going to allow you to orbit around your scene. Like this. You can rotate. Awesome, awesome, awesome. See how it keeps your cursor right where you left it? That's exactly what we want. What's the keyboard shortcut for the pan to move your scene left, right, up, and down? Alt-Shift or Option-Shift here on the Mac. You got it. Option-Shift, left mouse button. That'll allow you to pan around your scene. And what about zoom in, zoom out? And if you say scroll wheel, I'm going to whip out my ruler. Okay. It's Option Control in combination with the left mouse button. Okay, so just write those down. Commit them to memory. At the end of the semester, you want to be able to work at the exact same speed your brain is working at. By forcing you to stop your workflow to just change the perspective within your scene, it's going to be a big hindrance as to how far you can go within a specific modeling session. Okay? If I catch you doing this, expect me to say something, because I will say something. You have to get used to, and this is something that this is not something that just this class runs into. Everyone, this is a problem for everyone as they're learning how to work with the software. Okay? Get it into your brain right now. One hand on the keyboard, one hand on the mouse. Okay? You're working both at the exact same time. It takes a little bit of practice, but we'll get there. Okay? Just commit it to memory, and you'll do okay. I wish there was a way that I could turn these off, because I absolutely would for everyone in this classroom. On the first day of class, I wish I could just remove those from my interface so you guys wouldn't have to deal with it, because it is a larger problem than you're aware of. Okay, so if you look at our lab assignment this week, you're going to be building some Lego bricks, and there's some inherent challenges associated with those Lego bricks. In that, we have to connect pieces to one another, right? We have to connect a circle into a square. Now, as modelers, this is kind of bread and butter stuff for us. This is how we earn our paychecks. We earn our living by connecting two very different shapes together into one contiguous piece that has the correct polygonal structure. Okay? There are many, many right ways and many, many good techniques to yield an awesome model. But there are some pitfalls that we can easily fall into if we're not watching carefully what we're doing. So let's kind of take a step back here and look at some of the ideas and concepts that will allow us to connect these two unique shapes together in a really intelligent, compelling way. All right. I'm going to start off by drawing a cylinder. Okay, and this is just a cylindrical circle that has 8 sides, and I'm going to center this just in the center of my scene. There it is. Let me turn my grid back on so you guys can see what's going on. So there it is just chilling at the origin. Now, when we're connecting pieces to one another, we have to be extraordinarily aware of how many edges each of the pieces has. So you can't do this blind. You can't do this without having some sort of cognitive connection to how many sides your cylinder has. I've created a cylinder with 8 sides. Rock and roll. So I want to keep that in my memory here. This is an 8-sided cylinder. If you've forgotten, though, maybe you created your cylinder and then you were compelled to go chat with your friend on Facebook, and then you come back to Modo, and you've completely forgotten how many edges construct the circumference of my circle here. Is there a way that Modo tells you? Yes. Don't you love the sound of all my rhetorical questions? Does anyone know? Does anyone know what we can do to have the computer automatically tell me how many edges construct this circle?
You can just double click it and look at the right corner.
There it is, and Randall has it perfectly correct. Okay. If you go into your edge selection set, let me just do edges. You can double click on that edge loop, and then in the bottom right hand corner of our OpenGL viewport, it's going to tell you how many of whatever component that you have, how many edge components you have selected. In this case, 8. Okay. Now this works for all the different component types. So if you're in vert mode and you select a whole series of vertices, it's going to tell you how many verts you got down there. Yeah.
Yeah. For mine, for some reason, the little detail things in the bottom right and bottom left are turned off. I haven't turned them back.
If they're turned off, I got to remember. Is it in the viewport properties? I think it is. If you go into viewport properties, okay. What is it? Maybe it's under drawing and control. I so rarely turn these off. Nope, I'm in the wrong form. Is it this guy? No, those are also viewport properties. Let's see. I think it's in our Modo preferences, Leland. So if you go to the top of the screen where it says Modo in dark, big, bold, go preferences. Is it in the viewport properties? Where I just missed it then. Where was it, Steve? Help me out. Yep. Where do you see that? Show viewport controls and information. That right there. Yep. Awesome. Thank you, Steve. Okay, great. All right, back to where we were. If I go into vert mode and select a whole series of vertices, the bottom right-hand corner is going to tell me precisely how many components I have selected, in this case 8. Okay, great way to very quickly understand how many edges a shape consists of. Okay, so we need to keep that in mind. When we're connecting two different surfaces to each other, we need to have the same number of edges on both surfaces. So in every sense, I need to have a cube who has an 8-sided opening on it. All right, so on the same mesh item, I'm going to draw a cube. Okay, and let's center this a little bit. Oops. I want to do this numerically. I'm just going to position this precisely at the middle of the X and precisely at the middle of the Z. Okay. Now before I drop the tool, let's think about what we need to do to this cube to make an 8-sided opening. 8-sided opening. There's a little bit of an interesting challenge. Let's experiment here for a second. Let's experiment. If I went in, and I'll just drop the tool, and let's do this. I'm just going to hide my cylinder. I'm going to show you guys a tool here, but you have to promise me not to abuse this tool. This tool will get you into a certain degree of trouble if you're not careful. Okay? It's we're going to subdivide this object, but we're going to use a very specific rule that's going to kind of keep it all. It's going to turn one polygon into 4. Okay? And if we select that cube and hit Shift D, check it out. Watch what happens. It's going to automatically slice that one shape into 4. So I've got it selected, Shift D. You're going to get this little popover. The default method is faceted. Just make sure it's faceted and hit OK. And boom, it's taken that one polygon and it's sliced it into 4. Let's do it again. Shift D. There it is. And now, look at this. We have a 4 by 4 little grid. Cool. Cool. This is precisely what I want. Because now, in the center here, what would happen if I deleted those polygons? I have an opening. If we double-click on the opening, it's an 8-sided opening. This is kind of what we want, right? Yeah. So there's a couple ways you can do this. Ultimately, what we're trying to get is a 16 polygon surface, so 4 by 4. Do it again. Shift to D one more time. Keep going. Hit OK. There it is, 4 by 4. Now, when you're creating your cube, you could also have created it with 4 edge segments. Yeah, you got it right. Hit OK. There you go. Now do it one more time. There you go. Good. There it is. Now 16 by 6 or 4 by 4, 16 polygons in that surface. Because what we're trying to generate here is an opening that matches the same number of sides as our little cylinder. So if I double click on the opening, you can see down here 8 edges. Awesome. If I unhide my circle, there it is. It's also got 8 edges. But what can you tell me almost immediately just by visually looking at the location of the circle in reference to the location and size of the opening? Yeah? Say again? I selected those 4 polygons on the inside, and then I just deleted them. So what's wrong with my picture here? It's big. Absolutely. Yeah, and that's it. It's big. The circle is too big, right? The circle is extending outside of my opening. This is bad. This is not what we want. We need to have our circle on the inside of our opening. So let's just make it smaller. I'm going to grab it, scale it down until it's something like this. I'm going to look at my scene from the top just so it's a little bit easier to see what's going on. Yay, something like that. Now, when we're scaling these down, it's important that we leave a little gap between that outside opening of the square and the inside of our circle. Okay, we've got to have a little gap there. And don't try to put them like right on top of each other. That's where problems exist. Okay, we don't want to put them right on top of each other. So here we go. Now we have the foundation for what we're trying to accomplish. We have a circle inside of a square. But are they connected yet? No. We need to bridge the gap. Okay? We need to fill kind of no man's land in between the square and the circle with a whole series of polygons. And it's really, really quite easy to do this. The guys down at Luxology have come up with a really intelligent way of allowing us to do this. It's pretty simple. Since we have the exact same number of polygons, or excuse me, since we have the exact same number of edges on the square as we do on the cylinder, we're good to go. They have to be identical, because what the computer is ultimately going to do is that it's going to take that edge segment and join it to that one. That one's going to get joined to there. That one's going to get joined to there, so on and so forth. So it's going to go through and look for a possible connection point from the circle to the square. The tool that we're going to use to do this is called bridge. It requires us to select some edges before we get started. I'm going to select the opening of my square, hold down the Shift key, and select the edges of my circle. And then if you look over here inside of our basic tools, there it is. There's bridge. Now, bridge is purely designed to connect edges to each other, which is why we had to do this inside of the edge selection system. And then once I left-click and add, you can see what it's done. It's added it. Woo! You might be getting or it's connected it. You might be getting a slightly different result on your screen. If you look very carefully on mine, right now, the number of additional edge segments that I'm asking the computer to generate is set to 8. I wouldn't do that. I'd put that to 0. And there it is. That's what we're after. One other option that is kind of important for us to be aware of. Right now on my computer, the Remove Polygons option is enabled. So it's deleting that center circle once it's completing the edge bridge command. If I turn it back off, now we have the original geometry in its current location. And this is what we are after. Okay, this is what we're after here. This is a good edge bevel or an edge bridge technique, because what we've created here is a circle that perfectly flows into an existing square structure. They're all quad polygons, they're all editable, and they're all compliant with inside the subdivision surface technique. Okay? This is what we are after in every sense. At the conclusion of every model, we should be looking for ways to construct that model inside of quad polygons, and we've done that here. Let's do it again. This time, let's increase the challenge. how would we need to slice up a square to make a 10-sided cylinder work within that? Go. Ooh, throwing down the gauntlet. I've done an 8-sided cylinder. Now I want you guys to practice this technique with a 10-sided cylinder. Give it a go. Give it a go. And if you haven't gotten the 8-sided one to work, I'll walk around and help people as we go through this process. Okay, everyone get this 8-sided cylinder to work first, and then go on to a 10-sider if you're done.
Is this right? So it looks like there's like some kind of...
Yeah. Right now, your segments is set to 29. Put that to 0.
Wow.
Yeah. Good. And I'd also turn off remove polygons to keep that inside. Yeah.
Okay.
There it is. Now you're done. Good. Mission accomplished.
Is there a way to like reset the default settings on Moto? Because it's like every time I come in here, it's like someone's...
Yeah, there is. If you go File Reset.
Oh.
Yeah.
Okay.
Now that's going to ask you to, that's going to close down the program. So yeah, it's going to ask you to save your project file before you leave. Yeah, Tam, what's up? Ah, yeah, massive, massive problems. Hit undo for a second, and let's take a look at what you have here. Drop the tool. Okay, now do me a favor. Double-click on the outside of your cylinder, your circle. On the outside of it, on the outside edge segment. Right here. There you go. Double-click. How many edges construct that circle? Nope. 32.
Oh my God.
Yeah, 32.
Can I change over here?
No, you can't. And I think the problem, what happened here, is that you hit that Shift D while this thing was selected, and it subdivided the interior of it. Okay, that's a problem, because we wanted to only do that on the square. So I would restart that circle there. It's not going to work, because we have to have the same number of edges on our circle as we do here on our cube.
So delete this one.
Yeah, delete it, make a new one. Yep. Yeah, Andre, what's up? You're having issues. Well, let's see if we can resolve some of those issues.
But I don't know how to fill in the gap.
Yeah, super easy. Select the edges. Hit the P key for polygon. There it is.
Oh.
Rock and roll. Freddie, let me give you a hand here. When you're rolling over, because that circle is still visible, seeing how it's getting that selection error, it's not knowing what to select. That's bad, because we might accidentally select our circle when we only want to select our cube. Double click on this. Now hit Shift H. Boom, now we've hidden that circle. Shift 8 is going to hide all the unselected components in our scene. Now you can make the whole without having to worry about selecting the circle. Yeah. Okay, Jose, I think you're having the same problems that that Freddie was just having. You trying to get an opening? Mm-hmm. Yeah. Go into your polygonal selection mode. Double click on, yeah, see how it's fighting it because they're both sitting on the exact same plane? Yeah. Double click on your cube. There we go. Now do Shift H. There we go. We've hidden the unselected components. Now we can very quickly go in and delete those 4 center ones and get up and running. U, I'm sorry, the U key is unhide. Do you have a tornado? Yeah. Okay, so not so bad. The person that was using this before you, put your segments to 10. Put that down to 0. Okay. And let's see, we're kind of good. Yeah, this is actually working. But your circle was a 9-sided circle, right? Well, yeah. It may be 10. It may be 10, but because you have 18 edges down there. So that means you have a problem with the opening. Remember, the opening has to have the exact same number of sides as the circle. So if you had a 10-sided circle, you got to have a 10-sided opening. Interesting challenge. Yes, you do. Yes, you do. Yes, you do. You can figure it out. I know you can. Let me help you out, Mal. Cool. This is a cool little trick because you're trying to delete these interior ones, right?
Yeah.
Yeah, and you can't because it's trying to select the circle at the same time, right? Mm-hmm. Double click on your square. There you go. Now do Shift H. That's going to hide all the unselected pieces, and now we can select just the polygons for our cube. Now hit the U key. There we go.
I do have the square on the summer.
All right. Now, do you have the same number of openings? Or the same number of sides, excuse me? Yeah. Cool. So it should work, right?
Yeah, but I have to delete it?
Are you trying to hook the square into the circle?
No, it was, I just click on the bridge and I click on the left and right click and it,
That's what it did.
yeah.
Okay, hit undo then. Let's go back in time then.
So when I click on the blue polygon,
So it does not.
That's okay. Keep going. Keep hitting undo. Keep going. Keep going. You're almost there. There we go. Okay. Aha. Okay. I think I see what our problem is here. We have a lot of interior geometry on our circle. Zoom in some. Drop your tool. Go ahead and drop the bridge tool because we need to work with our cylinder here. Okay. Go into polygon mode and double click on that guy. Aha. I think I see what our issue is. We actually have two pieces of paper right on top of each other.
So I delete it.
Put your cursor right there and click on the outside of your circle. Yeah, select just the circle now. Good. Hit the H key. There we go. And now with that hidden, we can delete those. We don't need those guys anymore. And then hit the U key to unhide. There we go.
Scroll.
Yep. How we doing?
I don't know. I'm trying to figure out the 10 seconds.
How many edges do we got here?
I was about to count.
Do you remember how to count? 16. So we got what? Too much, right? Yeah. Remember, it's just basic math. 10-sided opening can connect into a 10-sided circle. That's all we're trying to do. How we doing? Good? Yeah, you got it.
It's just I'm trying to. I wanted to make it bigger than that, but
What do you want to make? What bigger of what?
I just wanted to fill in more of the, fill out more of it.
Well, that's okay. We can do that later. Yeah.
It's because I don't know, it just bugs me if it doesn't fit, well in there.
Yeah. Yeah, and that's okay. We're just getting the structure down, and then we can always go back and edit that structure later to get precisely the size that we're after. Yes, ma'am. He's not doing it. Okay, let's take a look. All right. Okay. Now we got 26 edges selected, so we've. Okay, let's go back in time. Hit undo a couple steps, and let's do some counting. That's good.
Right here?
Now just double click on this edge segment on the opening for
This one here?
that one. So 16, right?
Yeah.
How many edges does our circle have?
10.
10. So what do you need to do?
I need to make 10, but it's not calculating right. I don't understand. 'Cause I'm doing the shift.
Let me give you a hand. Four by 4, right? What would happen if we just made it odd? Like a 5 by 4. Yeah.
I think I've got my
8-sided square. Is that what you mean by 8-sided?
That's and I think this is I misspoke. This is a 8-sided or an 8x8
Right,
square.
right.
We need like a 4x4.
Okay.
Yeah, so
How
it's
I know how to increase. How do I reduce?
I think for this one, probably what you want to do is just delete some geometry. Delete half of your, delete what? So we need 4 rows this way,
okay.
and then so everything. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. Let me show you another trick, because you're selecting portions of your circle too.
Oh, yeah. Let's see. If I could.
Let me help you out.
Okay.
Double click on your geometry. There you go. Now do Shift H.
That'll hide it.
That'll hide the unselected pieces, which is the circle. Now we can edit our cube without having to wonder and worry that we're accidentally editing our circle. All right, ladies and gentlemen, just real quick. I know you guys are working on your 10-sided circle, and I wanted just to kind of bring an idea to your attention, okay? You've been successful in connecting your 8-sided circle into an 8-sided opening, but when we increase the number, the math has to change a little bit, as does the pattern. The inherent challenge that we're working with, or when we're working with 10-sided circles, is this. We don't get a north, south, east, and west pole. On a 10-sided circle, we have a vertice directly at the north side of our circle and a vertice directly at the south side. But we don't have one perfectly in the middle on east and west, right? Problem. Well, a problem that we just have to be aware of. Let me zoom out a little bit and to show you what the challenge that I'm currently working with. Look at my opening. Look for the landmarks. Look for those north, south, east, west poles, those north, south, east, west vertices in the opening. Where do you see those poles in the square opening? If you look carefully, I have 2 verts at the north, 2 verts at the south. But on east and west, I just have singles. These are the poles, right? I like that. It matches the pattern of our circle, but we need to make a change to one or the other. Does anyone know what that change is in order for these two things to connect correctly?
Rotate the square 90 degrees.
Yeah, or rotate one of them 90 degrees. It doesn't make a difference if it's the square or the circle. In my case, I want to leave the circle where, or excuse me, I want to leave the square in its current location. And if I grab my circle, rotate it 90 degrees. There we go. Now, east or west, east, west, east. I have 2 verts up here for the north, 2 verts up there for the north, 2 on the south, 2 on the south. Now these will connect together cleanly. Part of 3D modeling is looking for patterns, looking for geometric patterns that naturally repeat inside the mesh, and then using those patterns as the connection places for all of our geometry. With everything kind of dialed, I can do my bridge, and everything's going to work fine. Let's take a look.
Like when I'm trying to take this, it wants to do the whole thing.
Okay, let's explore. Zoom in. Zoom in on that corner there. Let's see what's going on. All right. See how that one's flickering?
Yeah.
That's an indication that something's definitely going wrong. Okay. Don't use those. Don't use those keyboard shortcuts. I should bring out my ruler. Yeah. Okay. So we got problems here. Let's zoom out a little bit and look for solutions on how to resolve that problem. Yeah. See how when you're mousing over here, it's also grabbing one there.
Yeah.
That's an indication that we have one big polygon underneath two little ones. Sometimes, oh no, delete it. I would delete it. Good. Now we just have to rebridge the gaps.
All right, then I'll just bridge these.
Would be probably better if we went there to there first.
Okay.
Ooh, zoom in. Check it out.
You got more stuff?
Yeah, zoom in, and then we can look.
I gotta do a lot of.
Yeah. I think Leland's suggestion may be the correct one in starting over. Okay, because here's the problem. Look, because we have an edge segment down there, that little small guy that doesn't go around. Well, it does actually.
Yeah, well, this one's connected.
It's got overlapping. Delete that polygon that got select that one. Delete it. Yeah. Bummer. Bummer. Yeah. You got to fix it. There's a lot of cleanup work here that you got to do to make this all compliant. All right, if you've done a 10, let's increase it a little bit. Okay? Yes, we can do it. We can do it. Do a 16. Do a 16-sided circle and connect it to a square.
That's just the 8th one.
Don't give the solution if you know the solution. What you got?
Did I do this right so far? Because maybe I just used like loop slice to make it be 3 and 4.
Yeah, you're close. You're real close.
When I bridge it,
Let's do some counting. Okay, double click on your circle.
this one?
Yep. 10. Double click on your opening. 6.
Oh, I forgot.
Yeah,
Forgot
we
those
need one here.
Yeah.
We need one there. And actually,
one out of it.
and then this one here. Whoops. This one here. This guy needs to be moved over so it matches that one. And then we need to add another one there.
Yeah, yeah. So that it.
Yeah.
I just.
You're close though. You're really close. Keep plugging away. Ms. Wood, yes. Okay, let's do it. All right. What we got?
I'm not sure how many times I'm supposed to.
Okay. All right. Let's stop just right there for a moment. Okay. So if we were to delete those 4 interior polygons, what would we get? Okay. Go ahead and do it real fast. Awesome. So we're almost there to our goal, right? Now we just need to add 2 more edge segments in here to get us up to 10. How could we add? Ooh, I'm sorry, I didn't mean to hit your foot. No, you're good. How could we add a couple more edge segments in here to get something? Could do bevel. Could do bevel. Bevel may work. What about using loop slice? Yeah, because we know the slicing tools will allow us to take. We use the tool incorrectly here. So drop the tool for me. Okay. Now with loop slice, we have to select some polygons first, right? We got to select some polygons that are connected to each other. Select that one right there. Oh, gotta get more than one. Gotta get 2. There we go. Now loop slice will work. Go ahead and click on the viewport to apply the tool. There we go. Now it's applied. Left click and drag. Or grab those guys. There we go. And look where we're adding edges into the mix. Not exactly what we want, right? But it kind of is a proof of concept to a certain degree. Let's do this. Let's go back in time a little bit and see if we can find a better solution to this. Hit undo a number of times, and we're going to hit undo until we get the opening filled. There we go. Okay. So if loop slice is going to give us the ability to add like one loop or even two loops, how could we like loop slice this in here? Let's give it a try. Hold down the shift key. Yeah, grab that one. Now run loop slice. The computer's going to select the rest, so we just need to get 2 or more. Okay. Now it's adding 2. We only need to necessarily want it to add 1. So if we wanted to add 1, yeah, absolutely. Great. Cool. And there it is. Perfect. Perfect. Drop the tool. Now let's delete some polygons. We need to make an opening, just like we did earlier. Yes, good. Now let's count the opening. Count the edges in the opening. Let the computer do it. Go to edge mode, right? Yeah, there you go. Ah, it didn't select the ones automatic. Try double clicking here. There we go. We got 10. Perfect. Now, if we look at the 10 that we have, we're really, really close, right? There's actually an edge right there and right there, and then we have one in here. Could we like space them out some so they're kind of more evenly distributed along up in here? Yeah. How would you do that? Could. We don't want it. What are you going to get if we were to do edge bevel? What would happen? Yeah, it won't look right, and it's also going to create new geometry. We don't want it to create new geometry. We just want to edit the existing stuff. So if we wanted to like move it, how do we move those 2 edges that I was just talking about? Huh? What if we just select them and then moved them and run the move tool? Grab that one, yep, and grab its neighbor down here. That way we can do them both at the same time. Now fire off the move tool. Yes. And what we're trying to get here is just a little bit more kind of uniform spacing between that one, that one, that one, and that one. Good. Good. That's going to give you a much better result now. Put your circle in there and see what we got. I think your circle's a little big, right? Yeah, a little bit big. Good. Now bridge it. Let's see what happens. Well, we gotta select the edges first, right?
Moto froze. I tried to bevel a
10.
line and it froze.
10. Perfect. Bam. Good job. Yeah. Andre, what you got? Okay. Let's see what we can see. Okay.
I've been trying to.
This is the 10.
Yeah.
Yeah. You're so close. You're doing a really good job. Yeah. So you've. No, yeah, you're doing a really great job. So let's analyze what you got so far. So you have a cube that's got 1, 2, 3 additional edge segments in it, right?
There should be 4. Oh.
1. Just do me a favor. Select. Let's get. We got 4 polygons in there. Yeah. Perfect. Okay. Great. So what we're looking to do is we need like a 4 by 5.
Yeah, I was trying to.
Yeah. Okay. So we got 4.
The 5 wouldn't show up.
Okay. What if we used? How can we take the existing geometry and edit it to get more new edge segments?
I'm unaware. Actually.
Say again.
I'm unaware.
What about loop slice? This loop slice is going to add edge segments in, right?
I forgot.
And then yeah, what are you going to put in there? How many edges?
Oh, edges. Yes.
Yeah. No, you had it right. Yeah. You Okay, the count is going to add new edge segments for us.
And I just click on it and I'll just,
Let's do one thing.
yeah.
See where it says symmetry there? Mode symmetry?
Yeah.
Change that to uniform. That way all the new edge segments are going to be evenly spaced.
Okay.
Give it a go now. Now, drop your tool for me and deselect your shape. That way we can more easily see. Ooh. Now we can just kind of more easily see how many we got. So we got, how many there? 6? Ooh, so we sliced one too many. So instead of having a hit undo, let's go back in time. Maybe one more step before the loop slice. Keep going. There we go. Now, so instead of a count of 5, what you gonna do? Yeah. And clicky click. Boom, there it is. A 4x5.
Yeah.
Good. Yeah, you're close. Loop slice is our friend.
Yes, they are.
To show, right, hit the 0 or the O key on your keyboard, and then in active meshes, it's right there, show vertices.
So I have a question. How can I divide into 3 of them? I have 4 of them, but I need 3. Yeah.
You need, yeah, okay, right. So let's see, just delete some geometry, right?
Yeah. Delete this one.
Yep.
Then this one.
Yep.
Then, how can I do
Perfect.
now?
Oh, I see what the challenge
I need
is.
3 polygon over there.
Yeah. Okay. Let me show you a cool little trick. Because we need to take this one edge and make it into 2 now, right?
Yeah.
Grab bevel. This is a cool little trick.
Bevel.
Bevel. Now change your edge shape back to round.
Shape like this one.
Yep. Now left click and drag. No. Left click and drag.
Left click.
And drag. Yeah. Oh, yeah. Keep going. Keep going. Keep going. Okay. See how we got a whole bunch in there?
Oh.
Why don't you lower that to 0? Lower the round level to 0.
Okay.
Ta-da!
But it's not like equal.
Yeah, so you'll have to do the same thing over here.
The 3 polygon is different size. So
Yeah, well, you have to do the same thing over here, right? Delete that one, and then do the edge bevel there.
I don't know. My question is, this one should be equal to 3 of them. Need the same size, right?
You could. I mean, if you wanted them to be equidistant between, you definitely could do that. Let's see. I think with what you have here, it's very difficult to do that numerically from what we have here. I just eyeball it.
Eyeball it.
Yeah, that's fine for now. Just eyeball it.
Okay.
Yeah.
You're supposed to rotate it to make it fit, right?
Yeah.
Okay, so you might have to rotate it some more.
Yeah. What I would do is that I would go in and select the edges that make the circle, and rotate them 90 degrees.
Also,
Or no, rotate them just maybe not 90 degrees, but just a little bit.
without having to go back and starting over from scratch, how do you add and subtract polygons? Like if you wanted to add more, like say if I didn't have this equals 16, how do I add?
Right. Yeah. You on the circle itself.
Yeah, without having to just start all over.
There's no way of doing it.
So just start
You just
over.
gotta start over. Yeah, it's gonna make a new
I did
circle.
that 3 times and I finally-
He's gotta make a new circle. That's got the correct number of sides. Circles are the one thing that we can't add more sides to after we've created them.
So I almost got this down, but I'm trying to rotate it, but it rotates the entire thing, and I can't separate it from.
Yeah. So drop what you got. Okay, and go grab just that center polygon, the circle. There you go. Now just rotate that. Oh, no, ignore that. You gotta hit the rotate tool. Yep.
Okay, that was my bad.
There you go. All right, I'm going to throw down a gauntlet here. The challenge continues. I've navigated back over to my 8-sider. I want you guys on your 8-sider here to delete that center circle. Just delete it. Delete the center circle to make an opening. Like that. Now, what I would like you to do is to put a square in that opening and connect a square to the rest of your shape. So delete the center circle. Once you delete that center circle, create a square that you will be able to connect to your circle. So you're going square, circle, square. Figure it out. What? It's squareception. I don't think I understand. Uh-huh. Yeah, I can't have that.
I just created a square straight up, and it had that problem.
Well, that's weird.
Yeah, it shouldn't be doing that.
No, I shouldn't be. Let me check it out. See what you got, because that's odd behavior.
Spin around it real quick. Put down here. Put these back. Here, look.
Okay. Where is that within inside of your scene?
That's from the bottom of the square.
The bottom. Okay. Hit undo to get to a point before you added that square in there. Now, how did you create that square? Did you use the cube tool or something
Yeah, I
else?
used the cube tool.
Is that overlapping geometry still there?
Yeah, let's go back to here.
Yeah, okay. Out of reduce. Okay. I think for now, just delete it and get rid of it. You know.
Why is it doing that?
I don't know. Without seeing precisely what you did, it's hard to say. Now, we didn't need to delete everything. Hit undo, one step. And let's see. You can delete just the friends around it. There we go. Now you're good, right?
I got a bunch of them.
Yeah,
Just from
let's do
creating
this.
it.
Instead of hit undo to return that, select everything. Go to the top of the screen where it says geometry. Do mesh cleanup. Hit OK. Hit OK once again. Is it still doing it?
Yeah.
Yeah, that's
And it's just-
weird.
There's nothing to clean up.
That's weird.
I think that's the reason why it crashed. It's
Maybe.
having problems.
Maybe. Another thing that I would do, and this is just a performance thing, close down Photoshop and Bridge. That's not a bad idea. Now, often when things go really weird, I start restarting things.
So you want it to have the same sides, right?
It's got to.
Okay.
Yeah,
How do we do the bridge?
the bridge. You've done the bridge.
I thought I had to have lines between them.
Ah, I see where you are. Okay, drop the tool for me real fast. We need to make an opening before we go any further. Put your cursor over here. Okay, yeah, right on that, the one to the left. There it is. Select that one and delete it. Here we go. We're going to delete all 4 of those. And once we have an opening, yes, good. Good. Now we can bridge it.
Just click on.
Whoop, we got to select some stuff.
Edge.
Yep.
Edge.
Double click on the opening. Oop, on the edges itself. I apologize. There we go. Yep.
Okay.
Now hold down the shift key and double click on the edges that constitute the circle. Now we can run bridge. Cool. And then just single left click anywhere inside your scene.
Okay, to activate the tool.
There it is. Yes, sir.
So what are we going to do with this? Am I going to try to bridge these edges together?
Yeah.
So maybe just subdivide it.
Yep.
It'll be 8.
Just connect a square into the circle. Yeah.
Thing you were showing, I kind of missed it. It was like you told us to delete the center.
You have deleted the center, right?
I have.
You have, so you're good.
That's it?
That's it? Yeah, you're good.
Okay. I thought there was like a little trick or something.
Nope. Mr. De Campo, how you doing?
I'm having a hard time making the Lego thing.
Uh-huh.
So I was just trying to copy the same shape and start. Do you say bridge when you?
No. Let's do this. Did you do the square to the circle?
The square in a circle? Not yet, but I was.
Let's do that first.
The square?
Yeah, make the square,
Yeah.
and then make an opening inside the square that has that will allow an 8-sided circle to bridge into it.
Okay.
Yep.
So you want me to click bevel or which one?
Well, let's do this. If we need to make an opening, right? Drop the tool that you have.
The tool.
No, drop it. You just applied it. No, you just applied something else. Drop the tool. How do you drop tools?
Drop tools like. Oh yeah, you click this one.
Okay, how do you drop it now? How do we disable it?
Oh, you have to select the polygon first.
Nope. Space bar.
Oh, space bar.
There it is. Good. Okay. So go select that center polygon.
The center, this one?
That's the one. Is that an edge or a polygon that you selected?
Oh, the polygon.
Yeah. There you go. Now do Shift D.
Oh, it's Shift D. Okay, Shift D.
There you go. Hit OK. Do it one more time.
Okay, it's Shift D.
Yep. Well, there it is. Good. Cool. And now what we've created is a 4x4 cube.
Yes.
Zoom in. Let's go look at it.
Yes. Okay.
Now use those keyboard shortcuts. Good. Good. How do you pan up?
You have to select them.
No. How do you pan up so we can see the top part of your cube?
Oh yeah.
Nah. No. What's the keyboard shortcut?
Shortcut. Option.
Uh-huh. That's rotate. How do you pan?
What's pan mean?
We want to go down.
Oh, go down. You have to press the shift then.
And option.
Oh, it's the shift and option.
Yeah, there you go. What's zoom?
Oh yes. This one.
What should we zoom? Not the scroll wheel. How do we zoom in?
Okay.
Good, you're close. It's option control.
Option control.
Just zoom in. Not the scroll wheel.
All right.
Okay, so grab these 4 in here
Okay. Okay. Oopsie.
and delete them.
Delete.
Cool. Now make a circle.
Okay, make a circle. This one? This one?
Mm-hmm. Now we got to be careful with this, okay? We need to make a circle that perfectly matches the number of sides this opening is, right?
Yes.
Okay. Before, let's drop your tool real fast. How do you drop a tool?
Drop a tool is, okay. Drop it.
Space bar. Good. Go into your edge selection mode.
Edge.
Double click. Okay, so it selects the opening, right?
Yes.
Is there a place within our interface that tells us how many edges we currently have selected?
Shift?
Nope.
No, not shift. It has to be, oh yeah, it's, 8 edges.
Okay, so we have an 8-sided opening, right?
Yes.
How many sides does our future circle need to be constructed with?
Okay, here's 1, 2, 3, 4. No.
No, just think.
Yes.
If we have an 8-sided opening,
Yes.
and we need the number of sides in our opening to match the number of sides on our circle,
Yes.
how many sides does our circle have to be?
8 edges.
8. You got it.
Oh, yes.
Now let's make an 8-sided circle.
8 edges circle. Do I have to click this one?
Mm-hmm. That's how you make a circle, right? Now, before we get started, how many sides does it need to be?
8 edges.
8. Where within your cylinder options allows you to determine the sides of your circle?
8 edges still.
Yeah, but where do we change that parameter?
You have to, you have to move the edge.
Nope. Remember, right there.
Oh,
Okay?
yes. This one.
Right there. That determines how many sides your circle is going to be constructed with. What does that value need to be?
8.
8.
Okay. I know this. Oops, I passed it.
Here we go. Okay, now let's make our circle.
This one. Okay.
Oops.
Let's make it this way.
Nope.
No. Sorry.
Make it again.
It's already.
That's good. That's good.
Okay, small.
Okay, hit undo because you just made a cylinder. We want a circle.
Oh, circle. This.
That's the one. Now, the reason why it made a cylinder is because you were holding down the control key while you were left-clicking and dragging. Don't do that.
It's this one?
No, you were in the right tool.
It's this one?
No, you were in. Go back to cylinder. Go
Oh,
there it is. Okay.
Oh, yeah.
Now, left-click and drag. Don't hold the control key down. That was the problem that you ran into last time.
Okay, left key.
Yep.
Okay.
Good. Now, you want to move it, right? No. That makes a cylinder.
Yes. Okay.
Use the arrows.
Oh, this arrows?
That's an arrow. Yep.
Oh, yes.
There we go. Good job.
Thank you.
All right, that's good. Drop your tool. Okay, now let's use the bridge. Let's do the bridge. Okay. Before we select the tool, we have to select all the edges on our circle, right?
Yes.
Because we have the edges for our opening done. Now we got to select those guys. Okay. Now how do you add the edges to the opening of our square into there?
You use the bridge thing?
Nope. How do we add edges to a selection?
You put.
Nope. Hold down the shift key.
Oh, this.
There we go. Now, if I wanted to add the edges around here to the current selection, what do you got to click on?
You have to click the P. No,
Nope.
not the P.
Nope. We're just going to add existing edges in there. Which edges do we want to add?
Copy.
No. You're trying to make something. We just want to add something that's already there, right?
Yes.
How do we? Okay. Point with your finger. Which ones we want to add?
This one. I want to add this one.
Yep.
Okay.
Yes. There it is. Double click. There you go. See how they select them all?
Yes.
Good. Now let's run the bridge.
Okay. The segment needs to be 16.
Nope. At 0.
At 0. Oh.
Now, how do you apply the tool to our selection?
Selection. Let's see.
How do you apply the tool?
You have to.
Nope.
Oh yeah, the.
Nope.
It's hard to think. Let's see.
And we're just gonna click. Click.
Okay.
There it is. Good. Now it's actually done its thing. Drop your tool for me.
The tool, spacebar.
Yep. Okay. Now start orbit around a little bit. Rotate around in your scene. Yeah. So it actually did its job. Just that cylinder was way above the plane of your square, which is why you're getting that cone. Is there a way that you could bring that little tip down?
Yes, I could. Oops.
Whoa.
I have to, mistake. I need to, select this one. Hold on. Let me, go back. And, there. That's better. Now, we do this.
Yeah, good. Use the arrows. Use the green arrows. Don't grab the cross. Grab the arrows.
Yes.
There we go. Good.
Oopsie.
Move. Yep. Fire it off again.
Again.
Now hit the W key.
The W.
There you go. Good. There it is.
Thanks.
You can even make it bigger.
I don't think you should have done the shift D. Should be segments, not this one. Is that this one?
Good job. Now, we have a little bit of an issue in here, don't we? Back up for me. Hit undo a couple steps before the bridge between the circle and the square. Keep going. Keep going. Keep going. There we go. Okay, let's do some counting. Drop your bridge tool for me. There we go. And let's do some counting of some edges. How many edges is your circle? Your circle? Count them. Yeah, double click on it. Let the computer count. 8. How many edges is your square? 4. Yes, good. There it is. Now do the bridge. Perfect. Good job. You got it. Sophia, how are we doing? Not good. You're close. Hit undo a couple times. Let's get out of here. Let's go back in time a couple steps. Okay, good. Let's do some counting. Drop your tool because you're an edge extend. Okay. Let's do some counting. How many edges comprise of you that circle, that outside circle? Yeah. 8. How many edges do you have on your square? 4. Is there a way that we can get 8 on our square? Yeah, let's give it a try. See what you get. Oops. What do you guys start with? There you go. Bingo. Now do the bridge. Bam. Good job. That's what you want. Yes.
Not giving z-axis segments. Let's give her the 5.
That makes sense. And right now, the way you've orientated your three-dimensional viewport, the z-axis is actually coming out at you like this.
Oh, Lord.
Yeah.
How did you return this?
If we just add 5 on the y, we'd get the result that we're after. There it is. What are we trying to do here, Abel?
Trying to add all segments so that I can start the whole thing over.
Yeah. Okay, let's do this. Let me help you out here a little bit. Drop your tool.
What the?
Deactivate it, because you got what tells you that a tool is currently active? This stuff down here, right? If you see options, that means a tool is on. We also get a highlight behind the tool that tells us the car is on. We want to turn the car off. Yes, there we go. Good. Now we're free to make a selection without having to wonder if a tool is influencing our scene. So I like what you're doing here. You're just trying to get it into like a 4x4 cube, right? Yeah. Let's get rid of some geometry here. Go into edge mode. You were close. You were close. Edge. There we go. Edges. Good. Now I want you to go in and put your cursor like right here. Hit the O key. Okay. Let's do this. Go into visibility and go into active meshes. Let's put the wireframe. What? Okay. Get out of here. Just click off of the form and orbit around your scene a little bit here. Rotate around. Aha, I see what's going on. Here's what I want you to do. I want you to redraw this, delete this. There you go, delete it, bye-bye. Okay, now let's make a new shape. Let's make a new cube. Yep, good, good. Now don't hold the control key down, okay? Just left click and drag. Drag out a square. All right, good, good. Now this is just a single polygon cube, right? You want a 4x4. What if we increase the segments down here?
These ones?
Yeah. Give it a go. See what you get. Okay. Do it on the next value. That one. Aha. See how it's adding edge segments in there? Do it one more time. There it is. Drop your tool and keep going.
I'm getting weird twisted ones.
Yeah, I think it's just you need to do like 3, 3, 3, and 3.
Yeah, the pattern of your circle doesn't necessarily match the pattern of your square.
How do I make the pattern of the circle match it?
Let's see. Let's see. Now, what are we doing? We're working with an 8-sided circle.
12-sided.
12-sided circle?
Maybe if I push these back farther.
Could, yep.
I'm thinking about doing that. I'm doing one at a time, though.
Yeah. Whoa, 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 whoa. Okay.
I don't know why it's doing
Hold
that,
on a
though.
second. Hit the O key. And go over here where it says active meshes and turn on show vertices. Yeah, okay.
Why do I have more vertices?
I don't know.
Because I didn't add any.
This is probably a result of maybe an incorrect deletion of an edge.
Oh, what I did is I subdivided up here.
Yeah, okay, so we got extra verts in there that we can't have. That's your problem. How are you doing, Leland? Getting it?
I'm scaling my Lego brick.
So I could just manually delete the vertices and it'd be fine.
I don't like the word random in that sentence, Rayu. What are you scaling your Lego brick to?
An actual Lego brick.
Oh, cool. Great.
You get the no, I didn't do that. He did.
I did not go over there.
Wow.
Steve is absolving himself from all responsibility.
Why is there a ginormous box in the middle of her?
All right.
This class is dysfunctional.
I love the dysfunction. Okay. So I'm very, very happy with the results that you guys have come up with. This is kind of the bread and butter stuff that 3D modelers are asked to do very, very frequently. It's to make a shape, then make a hole in that shape, and then to connect another shape into that hole. Okay? Now there's some practical real-world application of all this as well. Okay? If you think about it, what we've designed here is a system that allows us to continue to work and flush this out into all 3 dimensions. Now let's just take my little 10-sider here as an example. Okay. If I wanted to make this the peg, if you will, on one of my Lego bricks, what do I need to do? Bevel it up. Right, we already have the geometry available to us. So now we can just bevel it up. Hit the B key, click on the viewport to apply the tool, and just drag it up, and there it is. Okay. With that said, however, let's talk about our subdivision smoothing technique that we were working with before. Hopefully everyone at the very least has one of these examples constructed on their screen. What happens when I hit the tab key? Looks kind of lumpy. And this transition down here at the bottom is certainly not what I'm after. So walk me through the process of shoring up some of these edges and retaining all these plane changes in my 3D scene. What do I need to add? Let's start at the bottom here and work our way up towards the top. How do we approach it? What do we need to add at the bottom of my scene here? Edges. But where? Where I don't want it to bend. Okay. Let's get a little bit more specific than that.
Do you need to add one out on the bottom faces, like go through all those, and then average vertices?
Nope. Nope. But you're theoretically you're in the right mindset. Technically, you're doing it wrong. But remember the rule, right? We find the original edge that defines the plane change. In my case, down here at the bottom, here's the original edge that defines the plane change. Because there's a plane and there's a plane. There's the edge that defines the location of that plane change. From that location, we need to add 2 more edges, right? Where do those 2 edges go? Don't think about tools yet, but just where? Where do they need to go? One on the what? On the corner, you kind of, but just think globally here. Where do these new edges need to go? Top and bottom, one above and one below the original. Just remember, think whenever I'm doing anything conceptual, I try to think as generally as I can. I've noticed that people often get hung up when they start trying to, put the cart before the horse, okay? Think globally first. I need to have one above, one below. Now that we know what we're doing, we get to choose the tools that are going to give us that result. And we have a number of tools that are going to get us there. What are some of the tools that will get us to that result? I heard it. Loop slice will do it. Yeah, absolutely. So we could definitely grab a couple polygons up here. Loop slice, Alt-C. Just going to left click and drag, put a new edge segment right down there at the bottom. And FYI, you can also do a loop down here. That's a loop of polygons. So loop slice will absolutely work along the base. Huh? For loop slice, how many polygons do you have to select within a loop to get the result that you want? 2. And now, if I hit the tab key, yeah, awesome. Good, good, really good. Let's focus our attention on the top now, because clearly we have some additional work that we have to define up here at the top. Here's the original edge that defines the location of the plane change. What do I need to add? Think globally first. Think conceptually, and then we'll approach at the tool stage. What do we have to add? Edges. Where? You got it. So one above and one below. We're sandwiching the original edge with an additional edge above and an additional edge below. Now that we know what we have to accomplish, what tools can we use? Bevel, absolutely. Okay. So we can run a little bevel action, and we just got to make sure that our edge shape is set to square. Then I can left click and drag. It will automatically go in and add the edge bevel and the edge segments, where I need them to go. Can drop the tool, hit the tab key, and I'm on my way. Rock and roll. Yes? I couldn't hear you. Say again? That's correct. Good, 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 good. Yes. I did the edge. I think you were doing a 10, right? Yeah, so it's a little bit, it's going to look a little different, but geometrically, that's right. Have you already applied the tool?
To this part.
Not down there? Yeah.
You have to do it together.
Yeah, that needs to be all one connected piece. Oh, but you already had 2 or more polygons selected. Select 2 polygons down there at the bottom. Okay, now run edge loop slice. The computer's automatically going to go through. Yeah, see, it automatically went through and selected it for you.
Okay, so then
I think we have too many down here. We don't need 2, we just need 1. And put the mode on free. There we go. Now left click and drag to determine the placement of that loop. Yeah, I'd bring it close, 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 close. Keep going, keep going. Yeah, somewhere, that's too close. Somewhere right around in there. Good, good. Yep, yep, you had it. Do it. Yeah, spacebar to drop the tool. Good. Now, hit the tab key, see what you get. Good. Good. Use the square. Yes. There we go. There we go. Yeah. Go back in time a couple steps, Mal.
Is this fine?
Yeah, that's good. Now do the edge bevel.
Oh, okay.
And then just make sure your edge shape is set to square. And left click and drag. Now, why isn't yours doing what it should be doing? That's interesting to me.
She broke it.
You broke it. Oh, that's D2L.
Okay.
Okay, drag up on that handle a little bit. Or drag down, excuse me. Oh, actually, it is doing what it is supposed to be doing. See, when you keep moving it down, watch this bottom edge. Once it kind of intersects with the existing one, then it starts pinching it. So just make sure it doesn't go past that one right there.
All right.
Yeah, you're good. You could even get rid of that one. You don't need that bottom one. Whoa. Yeah. Let's see what you got here. Yeah, I don't know either. No, I think you're pretty good. I think at the moment you got the structure already. You're good. You don't need to do any additional bevels. Good. All right. Any questions on what we've explored this afternoon? Yes, sir. Yeah, that's because you don't have a selection, right?
I select this one.
Loop slice works with a polygonal selection, not an edge selection. Yeah, there you go. Yes. It will. It will. It's going to, remember, this entire shape is under tension, so it's going to shrink ever so slightly. Yeah. Yeah. Yeah, sub-Ds are always just a little bit smaller than their non-sub-D friends. What you got, Andre?
Like this part right here?
Yeah, good. Okay.
Because yours is so bad up there.
Let's do it.
How do I do
Drop your tool, because the top is looking banging. Hit tab. Okay, now we're so close. Zoom in down here at the bottom. Let's count some edges, right?
Yeah, one.
There's one. There's two. We're just missing one down here.
Oh,
Yeah.
how do I do so?
How do you do that? Maybe.
Oh, like, sorry.
Yes, 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 yes. Yes, 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 yes. Yes. Keep cruising. Yes, yes. How many are you going to add?
One.
Perfect, you got it. Oop.
Yep.
One thing that I would change before you click. Right now the mode is set to symmetry. Put it to free. Now go. Now where did it get? It's kind of like out over here. Left click and drag and it'll move it for you. That's the cool thing about free, is that we get to determine where it wants to go. Yeah, right around there. I think that's good. Good, cool. Drop your selection. Just like click here in the background. There you go, now hit tab. There it is.
That's much better. Thank you.
Good job. Okay, let me help the folks in the center. What we got?
Because all I'm seeing is X and Y right now.
Mm-hmm.
I just think it'd be easier for her to model on the Z axis.
Yeah.
So how does she get back there? Because I've been turning and rotating it, I couldn't find it.
Whoa.
Exactly.
What did you guys do?
I didn't do it.
Yes, you did.
It wasn't me. With both of us. Maybe you have to just start it over, like the whole program. Yeah, it's just, I don't know, it's really weird.
Okay, I think I see what's going on here. Has it always been behaving like this today?
Yeah, she's
Yeah.
been turning and it's just been really strange.
Someone has done you an incredible disservice. No, it was not you. And this is something that I don't change. I don't ever tell people to change this, but I'm not the only person that teaches 3D here, and I'm afraid someone has changed this. And I do it so infrequently that I don't even know where in here the option, here it is. No, wait. Remapping? Yeah. Someone has gone into your units and they've changed it to be the Z is up. We want Y up. I don't know why someone would do that, but they did. Now, everything is work. Okay, let's get it. Now everything's going to work the way it should work. Let me just jump in here just real quick. There we go. That's working. I'm also going to give you a hand. It's much easier to use all the tools when we're drawing control. Put your trackball rotation to no. It's going to be a little bit easier to use the orbit command. It's going to feel a little bit more natural. There we go. Now, the sky is Y, You know, positive y, the dark is a negative y. Things are good.
Yeah,
Now we're back. Yeah. Yeah, that's a good one. Welcome to an open lab environment. What you got?
I'm not sure if this is wrong with my geometry.
Ooh, it may just be, maybe. Let's drop your tool, hit undo to get back to the point before you did the loop slice.
Yeah.
I think it's a geometry problem. Now, there's a couple things in here that are telling me that it's a geometry problem. Visually, how many polygons you got selected?
2.
It says you have 3. Yeah, there's duplicate geometry right on top of each other.
Okay. So mesh cleanup?
Mesh cleanup. What I would do, I'd do it on everything.
So
Double click it.
okay.
Oops.
I gotta like that.
Yep.
Okay. All right. No.
Yep, just passed it.
No. Here we go. And
Good.
all right.
Good. Cool.
All right. Now we try.
Let's see if it works. There it
Yeah.
is.
There we go.
Huzzah. Okay, folks, real quick, let's get back together as a class here. Just want to talk about some really important concepts before I let you guys to continue finishing your lab work and start on your homework. Now, we've been focusing all of our energy this afternoon working with basically a 2-dimensional plane, right? Well, we're going to be making a 3-dimensional cube, right? Or a 3-dimensional Lego brick that's primarily a cube. So let's talk strategy here. Let's talk strategy. A lot of 3D modeling is kind of approaching things like a chess player, thinking 8 or 9 steps ahead so that what we do here on step 1 sets us up for victory on step 9 or 10. If we're going to end up, if our end result is a Lego brick that's basically a 3-dimensional cube with a whole bunch of little, cylindrical pegs sticking out the top, where are we going to start?
Start with the brick, and then you're going to do something like this to hold the pegs up.
I like it. So start with the cube first, right? Don't start with the plane. Because how are we going to transform a plane into a cube? You'd extend the edges, but then it's not a closed cube. Yeah, not impossible. Not impossible. I'm not saying that's wrong, but if we think strategically about this, we can certainly save ourselves a lot of heartache. Okay? If we start with the cube, and then loop slice the cube, or do Shift D on that cube a number of times and slice just the areas that we want to work with, the end result will be faster to get to that end result. Kind of make sense? Yeah. So think like a chess player. Think 8 or 9 steps ahead. This is not how I would start this project. Okay? This is just a theory. This is just kind of practice, if you will, on the technique that will allow us to get to that end result. This is not how we want to continue to work. Okay, other questions? Let's revisit both the expectations for the homework and the lab, because there are some things about the homework that I directly want to address and continue to talk about before we kind of scatter and take advantage of our lab time. Okay. So, oh, by the way, on our lab assignment this week, I've given you guys some diagrams of how we can connect all of these pieces together. Okay, so this is kind of a wireframe example of what it should look like for both a 8, a 10, and a 12-sided a circle being injected and bridged correctly into a corresponding plane. Okay, so a good diagram on how the wireframes are supposed to look. If you look carefully here, there's a pattern that looks familiar both on 8 and 12, right? The 10-sider looks a little weird, the one in the center, right? Why does it look weird? Look for patterns. Yeah, absolutely, and I think Randall's zeroing in on it. I like that. If you look carefully on the 10-sider here, we have 3 kind of horizontal lines cruising through, and then we only have 1 vertical line going this way. When we compare the pattern of the 10-sided to the 8 and to the 12, these have cross this way. This one has a cross going that way, but then it has an equal number of horizontal spans on the top and the bottom. Okay, this is good. This is awesome. This is exactly, precisely what we're after. Okay, that's the type of pattern that I want you guys to start looking for. I'll be honest with you, I very, very rarely use a 10-sided cylinder. Very rarely. Okay, 8 and 12s are where I hang out most of the time, because on an 8-sided cylinder and on a 12-sided cylinder, you get those all-important cardinal poles. Okay, and specifically what we're talking about here on my 8, or this is the 10, you know, on an 8-sided circle, you get the cardinal poles, 1, north, south, east, and west. Okay. On a 12, you also get those cardinal poles. North, south, east, and west. And then we have some extra guys here on the outsides, but those cardinal poles are really important for us, okay? They allow us to cleanly connect these shapes into other existing surfaces without too many issues, okay? 8 and 12, that's where I would like you guys to hang out. When we pair an 8-sided cylinder or a 12-sided cylinder with our subdivision surface algorithm, it's going to give us a really good quality result, more than it's not, okay? It's awesome. All right. So for your lab assignment, as you saw, and as you guys have already started to build, we're going to be building some Lego bricks. And there's some really great examples of some successful projects down below. As a small little reminder of the expectations, let's just go over them. So a Lego brick with at least 6 little nubs on the top. Okay, you got to have 6. At least 6. You're more than welcome to do as many more as you like, but it's got to at least have 6. Materials and textures for all elements, okay? So go through and add materials and textures.
So I've got an equal number of faces on my circle and on my square, and I just bridged them, but it's twisting around.
After the bridge, or even before the bridge, you can rotate one of those elements to get it all the features to line up correctly with the element that you're bridging it to. I'd recommend rotating the circle, so that the points on the vertices on the circle matches some sort of feature on the cube. So a couple things: shadow catcher and studio environment preset. Let's explore this. Okay, let's explore this because we didn't talk about this last week, and these are really kind of neat additions to our rendering setup. Okay, I want to go back over here to Modo and just make a new scene, and inside of this, I'm going to make just a little teapot. There's my little teapot, looking great. Let's go to the Render tab now and focus on how we can employ both these shadow catchers and studio environment presets. With the default scene, this is what we get when we add in just a basic piece of geometry, right? It looks as though it's kind of floating in this gray environment, and you're absolutely correct. It is floating in this never-ending, ever-expansive gray universe. We want to make it look like it's sitting on top of a gray floor, like it's grounded, and it's producing some sort of ground shadow on, in our scene. The guys down at Luxology have come up with a really neat system that allows us to add this ground shadow in without having to physically add some sort of table or like sidewalk that my little guy is going to sit on. I still want to see this gray background, okay? It's called a shadow catcher, and you can add a shadow catcher rather easily. I'm in my Render tab. Down here at the bottom, we have a number of different tabs, one of which is called the Render Preset Browser. Now, inside the browser, you're going to get this cool little hierarchy. Okay, this is, you can navigate around through your entire hierarchy through these up and down arrows. But I like doing it through this pull-down menu because it allows me to very quickly go to a number of different places. And I'm going to go to Meshes. And the shadow catcher can be found in the Basics folder. And there it is. Double-clicking on the shadow catcher will apply it to your scene. And if I zoom out, you can see what it looks like. Okay. Now, right now, we're cutting off half of the geometry for my little cube, right? But you can see the illusion that we're crafting. We're getting a shadow now, and it looks like this object is grounded. No, I don't want it to cut off half of my geometry. So if I go back into the Model Single tab down here at the bottom, we can kind of see what it's doing. That big black square is the shadow catcher. And if we examine the contents of our item list, we have a new element called shadow catcher. I can select that polygon. It's nothing more than a polygon, okay? I can select that polygon and just move it down until I'm happy with the result. Let's see, and you can do this with a little bit of, that's close enough for me. You can do this with a little bit of accuracy. Something perhaps like that. There it is. So there's the shadow catcher. And what we're getting is the illusion of a ground plane without having to render the big polygon that it's actually sitting on. Okay? That's a shadow catcher. I would like you guys to use the shadow catcher for your assignment this week. Okay? I'm sorry, say again? Then you can't render on your laptop. Sorry, Steve. And if you don't have it on your laptop, what's missing is the content that comes with the Luxology install. If you're a registered product owner, you can download the content in your registered products section of the Luxology website. If you're not, then I don't know what you're going to do. Yeah, go to the lab, and that's the answer. I mean, just render it here. Go to the lab. It won't take that long. We have it all. Okay, the other thing that I want you guys to add is a studio environment preset. I don't like gray backgrounds. I think gray backgrounds are dumb. I think gray backgrounds are boring. They're uninteresting. I want my objects to look as though they were maybe rendered in some sort of like photography studio. Or maybe I want to use a HDR reflection map of some city to make it look like my little guy is sitting on a city street. Okay? I don't necessarily need to generate all this geometry to make the backgrounds of my renders look realistic. We can use photographs. Inside that exact same render preset browser, we have a category called environments. So I'm going to go out of the basics section, and I'm going to go up. And you can see that I have a category here called environments. If you look at the way that they've organized this list, these lines here are really important as they separate the categories from the subcategories. Right now, I'm in the meshes category, and I'm viewing the basic subcategory. I want to go into the environments folder. There we go. This is a master folder. There it is. And you can see that we have a number of subfolders inside of that location, one of which is called Studio. We also have indoor and outdoor. These are pretty cool. Just for illustrations, let's just do outdoor, and then you're going to get a whole series of images. Let's do outdoor spherical too. If I double click on it, it's going to load that image as an HDR reflection map into the environment of my render. And now you can see that paired with the shadow catcher, my little teapot looks like it's sitting outside. Okay? This is actually doing more than you know behind the scenes. It's not just a picture showing up in the background. This picture is actually having an influence on the global illumination system inside of our rendering world. So the colors of this environment map are being infused onto the native color of my little teapot. So a really neat way. This is how the big dogs do all of their rendering. They use global illumination paired with environment maps. Because now we're absorbing colors from the picture, if you will, in the background, and using that as color information on our sphere. To further illustrate this, check it out. Watch what happens when I turn off my directional light. I'm just going to go find it in my item list, turn off the visibility of it, and now my teapot actually looks like it's sitting in this environment. Okay? It's being entirely illuminated by the colors of the environment map that's sitting behind it, which is pretty neat. If we continue to navigate our hierarchy here, here's the studio ones. These are really cool. I use these studio ones all the time. Let's see, if we do 3-point blue, yeah, there we go. Okay. Now it looks a little funky. If we navigate our scene a little bit, maybe put some of that blue in the background. Here it is, and I can go into my mesh. Maybe rotate my mesh around so that it kind of gives me the illusion that I'm after. Whoops. There we go. Ta-da! Awesome. You can even throw that directional light in there, and that's a good render. Okay? So that's what I want you to use for your homework this week. I want you to incorporate a shadow catcher, or for your lab, I want you to incorporate a shadow catcher and one of these HDR studio reflection maps. Okay? It's like instant production value. It makes your object look as though it's sitting in something a little bit more substantial than a never-ending gray background. It's in the meshes folder. So if you go into your render preset browser, this is how I navigate it. I go into this bar right here, Andre, and I scroll up until I find meshes, and then it's just in basics. Shadow catcher. Other questions? All right, great. Let's go back to renderography and look at some of the other parameters for this week's homework assignment. Please make sure that you're rendering this at 1280 by 720. 1280 by 720, okay? Everything gets rendered at 1280 by 720. In addition, please make sure you're saving the rendered image for your portfolio and for this assignment in the JPEG file format, okay? When you're done with your lab, just make sure that the LXO and the rendered JPEG get submitted to me on D2O. Here's the naming conventions that I would like you to use. This is due by the beginning of class next week, and it's worth 25 points towards your total grade in the class. All right? Questions on your lab work? And I just realized a typo. That should say week 7, not week 6. I apologize. All right, so that's our lab. Let's look at our homework real quick. You're going to be making a stoplight. Okay? A stoplight. This assignment comes directly out of the book, so if you have the book, you can find the step-by-step resources on how to complete this. However, you can complete this if you don't have the book, just by looking at the imagery that I provided to you on the website. I've also given you guys a time-lapse video that walks you through this project if you don't have the book, so at the very least, you should still be able to get this assignment done. Now, at the core of what we're trying to accomplish here is a subdivision surface object. If you look critically at the shape that we're making, we are attaching, once again, spheres to circles, or circles to cubes, okay? The hood of the stoplight needs to be beveled out of an existing square that makes the back or the base of our little stoplight. In addition to making stoplights, you're not actually making one stoplight. You're actually making 3 stoplights. So here's 1, 2, 3. 3 different stoplights, of course, naturally for red, green, and blue. Please make sure that you're using your power, your prowess, if you will, in your shader tree to make it red, green, and blue on each one of the lenses for the corresponding stoplight. One other thing that I would like you to do this week, in addition to fleshing out the geometry, is start to think about how we can place this object in a little itty-bitty scene. You can use backgrounds, you can use geometry, but I would like you to start to think about context. Start thinking about modeling for a render, not modeling just to make a cool shape or just to make an awesome object, okay? We're modeling to generate a render. So that render is going to need to include some contextual elements that allows the audience of this render to understand what they're looking at, right? To understand the size, the shape, the scale of this object in relationship to the background. So this artist chose to physically make some very simple geometry, texture map on some images of some concrete, some curbs, some windows and doors, and made a little scene. Others chose to utilize their skills with their backgrounds to create the images that you saw before. Either is acceptable, but going forward, starting today, everything in here needs to produce a render that has context, that allows the audience and the viewer of our render to understand what in the world they're looking at. Because 9 times out of 10, if you were to take away the background elements from any object, you're going to get confused as to how big it is, to what it is, to the spatial relationships between all the different features within the object and the scene itself. These are important compositional elements that will ultimately make your portfolio renders a lot stronger. Okay? I think a lot of people, and I kind of find myself getting into this from time to time. We make models because we want to make a model, right? We don't necessarily consider what the final render is going to look like on the onset of our modeling kind of duties. But we need to, okay? Every project in here going forward needs to be rendered through the lens and through the idea that you're going to put this on your portfolio at the end of the class. Okay? You're going to leave this class with maybe, if you do a good job and if you take it seriously, 6 or 7 really good projects that you can put on a portfolio. If you start thinking about how those are going to be presented and the renders that are going to be used, this is an excellent, excellent opportunity to make some good stuff. Okay? Questions? So remember, backgrounds and scenes going forward for everything that we do. This is now, week 6. You're gonna find that over the next couple of weeks, I'm going to continue to kick the training wheels off and kind of ratchet up some of the expectations for these projects. You're now out of the infant stage, if you will, of 3D modeling. You're in the toddler stage now. You've graduated from infant to toddler. You're no longer just sitting there. Now you're walking and falling down and bumping into couches and chairs, okay? In the next couple of weeks, you will be what comes after toddler? I don't even know. Adolescent. That's a big jump, isn't it? From toddler to kid, yeah. We'll go from kid to preteen to adolescence, and then maybe you will achieve adulthood in the next 15 years. I just earned my adulthood kind of stripes, so it really does. It takes a long period of study to be good at this stuff. I'm just being silly. Yeah.
Did you go to the spread angle for the direction?
I didn't. Thank you for bringing that up, and I apologize. Yes, that's actually something that we should consider and talk about. I forgot to add that. It's actually a really easy, simple thing to illustrate and to see. Look very carefully at the type of shadow that my directional light is creating on the floor of my scene. What's it look like? Just look at the shadow. That's all I want you to look like. How would you describe that shadow to someone? It's pretty simple. It's pretty crisp around the edges, right? It's pretty dark on the interior. This isn't real. Okay? This is not how shadows look at all, actually. Unfortunately, we're in a lovely kind of cloudy, blustery day, but if this was a normal sunny California day, going outside and sitting in the sun would yield a very different shadow than what we see here. Shadows lose their energy, if you will, as they travel further and further away from their source. It's a naturally occurring phenomenon. We can't turn it off. If you were to go outside and look at your shadow on the ground, you'd see it. It'd be very dark and crisp next to your feet, but as that shadow goes away from you, it's going to start to blur and soften towards the edges. Okay? Well, we can simulate this very easily inside of the computer through a property called the spread angle. Let me show you how to change it. It's really, really easy. I'm going to select my directional light in my item list. In the Render tab, all of the directional light properties are brought up over here on the right. And if we keep cruising down, keep cruising, there it is, spread angle, right there. Its default value is off. Watch what happens to the quality of my shadow, or just the effect of my shadow, when I increase this to, like, I don't know, 10%. Look what happens. It gets much softer right around the edges, okay? That's the spread angle. All shadows have a little bit of softness towards the edges of that shadow. By turning this on, we're more closely recreating what we see out there in reality. You can't find it? Yeah, it's in your directional light. So make sure you have your directional light selected in your item list. And in the Properties tab, it's kind of down here towards the middle. Spread angle. So just make sure you turn this on when you're doing the render for your homework this week. Did you find it?
Nothing. All right, let's see.
Just past it.
Spreading.
That's the one.
Yeah, I was in a different spot. I wasn't in render, so it was like short.
Right. And if that ever happens again, Ray, you check this out. This is actually kind of a neat thing about how the Moto system, kind of displays its interface. If you're in, let's say, just the Model tab, for example, I got my directional light selected. However, I'm not seeing all of its options. Anytime you see a little button that looks like this, Click on it, okay? That's going to bring open a little popover that's going to show you the remaining properties inside that form that are being cut off by the edge of your interface. That's what those little double arrows mean. It's an application-wide interface element. You see it all over the place. Okay. All right, and as always, 1280 by 720, please make sure you're rendering a JPEG. I've given you the naming conventions that I'd like you to follow down at the bottom. This is also due at the beginning of week 7, which is next week, by the beginning of class. Homework assignments worth 50 points. Are there any questions? No? No? All right, we got a couple minutes left in class. Let's get started on your lab work and your homework. All right? Let's do it.